The dozer blade took the first round 3 feet from the operator's head. Hot steel shards and pulverized volcanic clay sprayed through the porthole. 1847mm shells struck that machine in less than a quarter hour. The blade looked like a colander, every hole a clean puncture where Japanese gunners had walked their fire uphill along the Villa Verde Trail. The operator, a sergeant from the 114th Engineer Combat Battalion, kept the tracks grinding forward. He was cutting a firing position for the tanks stalled behind him. Visibility through the armored glass was down to a slit in the dust. Around the next bend, a machine gun opened up at 20 feet. The rounds chewed through the porthole and nicked the operator's shoulder, then sliced the control cable. The blade dropped. Dead weight against the volcanic slope. The sergeant reversed, pulled back around the bend, and a tank rolled past him to finish the gun with a single high-explosive shell. The engineers spliced the cable in 45 minutes. The dozer was back cutting into the mountainside before the smoke cleared. On that trail, the difference between a road and a grave was measured in minutes of repair time. That fight on the Villa Verde Trail was still months away, but the scaffolding for it, the organizational machinery that would deliver replacement cables, fresh operators, and the authority to push a combat road through a 4,800-foot mountain pass, was being assembled right now, in the closing weeks of 1944, inside a converted department store in Manila and the cluttered offices of Far Eastern University. The men making those decisions were not pulling control levers under machine gun fire. They were pulling organizational levers, and the resistance was almost as stubborn. The central problem had been festering since the first base sections were carved out of the Australian outback. Engineer construction, airfields, ports, hospitals, pipelines, the entire physical foundation of an advancing army was controlled by base commanders who were not engineers. A colonel in charge of a base section could decide where a runway went, how many men were assigned to build it, and whether bridge timber got priority over a warehouse floor. The engineer officers on his staff could only offer technical advice. They could not command. The result was a sprawling patchwork of local decisions, each base commander fighting for his own resources, with no theater-wide construction strategy binding them together. Leif J. Sverdrup had been watching this system grind against itself for 2 years. As the acting chief engineer for the Southwest Pacific area, he saw the same pattern repeat. Materials ordered in duplicate, one base hoarding cement while the next one begged for it. Engineer units shifted between commands like borrowed tools. In late November 1944, his operations chief put the problem bluntly in a memo. It was time to create a proper engineer district office, one that could hire Filipino civilians en masse and free the troops for direct combat support. Sverdrup agreed. He went further. He wanted a single centralized engineer command that would control all construction across the entire communications zone. The politics of it were delicate. Base commanders would resist losing control over their construction assets. The services of supply headquarters would have to agree to cede authority. Hugh J. Casey, the chief engineer who had returned to his post in February 1945, backed Sverdrup fully. On the 20th of February, Sverdrup formalized his argument in writing. Concentrated construction forces under a single engineer commander, he wrote, meant far greater efficiency. The existing setup was dispersing effort across too many independent fiefdoms. Casey agreed, and the decision was made to place the new command directly under the commanding general of USASOS. The name of the new organization was the Engineer Construction Command, ENCOM. Sverdrup took command. His headquarters was assembled from scratch, drawing officers and enlisted men from a construction brigade and several aviation battalions who were pulled off their projects on temporary duty. 2 engineer districts were already operating, one on Leyte, one on Luzon, and both were transferred into ENCOM's control. A third was being formed, that one. The General Engineer District was Colonel Robert C. Hunter's domain, and it had a novel mission: rebuild Manila using paid Filipino labor rather than combat troops, freeing the soldiers for the coming invasions. The Manila operation ran on paperwork as much as on concrete. Colonel Hunter's staff, 150 officers and 300 enlisted men, had been recruited straight from district offices back in the States, given a few weeks of training at Fort Belvoir, and flown to the Philippines in late March. They settled into the 3rd floor of Far Eastern University, unpacked their typewriters and drafting tables, and began carrying on business as usual while the city still smoldered outside. The physical weight of the transformation was in those documents: the AFWSPACO logistic instructions, the base development plans, The tables of organization that shifted engineer authority away from base commanders and into the hands of men who understood how asphalt bonded to coral. On the 5th of February 1945, while the organizational scaffolding was still being hammered into place, General MacArthur issued the operational directives that would test it. 6th Army was ordered to destroy the Japanese forces holding northern and eastern Luzon. 8th Army was directed to seize a chain of islands across the central and southern Philippines, Palawan, the Zamboanga Peninsula, the Sulu Archipelago, and then Panay, Negros, Cebu, Bohol, and finally Mindanao itself. These were the Victor operations. They would be amphibious assaults. They would require ports, airfields, and supply dumps built at speed on hostile shores. The numbers alone told the story of what was being asked. Samuel D. Sturgis Jr., the 6th Army engineer, had to support 3 simultaneous corps-level advances through mountain terrain, where the Japanese had rigged every bridge for demolition and seeded the roads with mines. The 8th Army engineer had to apportion a relatively thin force of amphibian, aviation, and construction battalions across 5 separate landing operations on islands, with almost no pre-war map coverage. The centralized command structure that Sverdrup was building would take months to fully mature. But the directives were issued now. The campaigns would not wait for the perfect organization chart. The engineers would have to learn the new system while already running at a dead sprint. The Northern Luzon campaign opened not with a clash of infantry, but with a race against geography. The First Corps line now stretched from the Ghost of Demortis on the Lingayen Gulf all the way to Bela Bay on the eastern coast, a narrow waste of the island pinched between mountain ranges. 200 miles to the north lay Apari and the broad food-producing Cagayan Valley beyond the Cordillera Central. But every approach road was a trap. The Japanese had withdrawn into the high ground, and 6th Army engineer Samuel D. Sturgis Jr. faced a brutal equation. 3 divisions needed to advance simultaneously through terrain where a single destroyed bridge could stall an entire corps. The Japanese had chosen their ground with precision. 2 routes led toward the valley town of Bambang, Highway 5, which climbed through the Tulavera River Gorge toward Balete Pass, and the Villa Verde Trail, a footpath for carabao and barefoot travelers that twisted 25 miles through hogback ridges. The trail connected 2 points, only 11 miles apart by air, but it climbed to 4,800 feet and clung to cliffsides where a single misstep sent men and mules tumbling into ravines. Sturgis decided to keep most of his heavy construction battalions under army control near Manila, waiting until the road ahead showed where they could be swung into action fastest. The Japanese had fortified Balete Pass as the key to the southern defense of the entire valley. They dug cave positions into the defile walls, covered the approaches with pre-registered mortar fire, and seeded the roadway with mines so haphazard that engineers often found fresh charges planted behind them within hours of a sweep. The 25th Division pushed north from San Jose, with the 65th Engineer Combat Battalion in the vanguard, and the engineers quickly learned that every bridge demanded probing for demolition charges before a single truck crossed. In one 3-day stretch, they cleared 3 separate minefields, then went back and cleared the same road twice more after infiltrators returned at night. The Cavalry Division had already been transferred from central Luzon, and its 8th Engineer Squadron was working the Bicol Peninsula to the southeast, constructing pontoon bridges over rivers clogged with drifting lily pads so thick they threatened to buckle the pontoons. Stretching cables bank to bank caught the vegetation before it could pile against the floats, but the fix required constant tending. Every theatre of the Luzon campaign was demanding the same scarce resource: combat engineers who could fight and build simultaneously, and there were never enough of them. It was February 21st when the real weight of the northern offensive began. The 32nd Division took the Villa Verde Trail near Santa Maria, and the 114th Engineer Combat Battalion received an order that read simply, "Widen the footpath into a combat road." The trail ran 25 miles through mountains that had no business hosting a military highway. Hard-packed clay formed the surface, but the grades were murderous, and in many places the path was cut into sheer hillsides with a vertical drop on one side and a rock wall on the other. The engineers dispensed with the basic principles of road building immediately. They cut from the bottom of the hill instead of the top, letting the overhangs collapse and burying dozers in slides that took hours to dig free. The Villa Verde Trail was killing machines as fast as men. Dozers slipped on the precipitous slopes and went down 400 feet into the gullies, where they could only be recovered by building access roads down to them. The rains came in late April and turned the clay into a grease that spun tracks without traction. The engineers reported that dozers dug themselves in and could not move. Meanwhile, the infantry had stalled at Salaksak Pass, where the trail turned east towards Santa Fe and Highway 5. The Japanese had read the ground perfectly. The pass was a natural fortress of interlocking caves and machine gun nests, and every frontal assault withered under converging fire. The stalemate dragged into dreary weeks, while the armored bulldozers slowly carved firing positions for tanks on slopes too steep for the infantry to dig by hand. On the Baguio front, 50 miles to the west, the fight was no less desperate. The 33rd Division was pushing up Highway 11, the old Kennan Road, toward the summer capital where the Japanese had established their northern headquarters. The 108th Engineer Combat Battalion had to seize 2 concrete and steel bridges across the Bawang River near the coast, spans that the enemy had mined with 400 pounds of explosives and covered with machine guns from the north bank. At night, an infantry battalion forded the river downstream, while a platoon of engineers crept onto the southern span with mine detectors. They pulled the charges from the stringers while a firefight crackled around them in the dark. 1 engineer was killed. The bridges were taken intact. The division poured across them, and Baguio fell on April 26th, a full month ahead of the breakthrough on the Villa Verde Trail. Far to the south, the Victor operations were now unfolding in real time. Colonel David M. Dunn, the 8th Army Engineer, was already spreading his limited amphibian and construction battalions across the Central Islands, where pre-war maps offered little more than blank coastlines. Palawan fell first on February 28 without resistance, and the engineers immediately began rehabilitating the airstrip at Puerto Princesa, readying it for fighters within 19 days. But the easy victories were deceptive. On April 17th, the 24th and 31st Divisions landed near Parang on Mindanao, and the engineers immediately collided with the island's real obstacle, a gorge 120 feet across and 35 feet deep, with the bridge demolished at the bottom. The 3rd Engineers of the 24th Division strung a cableway downstream and got jeeps and howitzers across, but the heavy vehicles needed a solid crossing. Erecting a Bailey Bridge across that chasm in time was impossible. The engineers looked at the gorge walls, looked at their demolitions, and made a decision that no field manual had contemplated. They drilled into the sides of the canyon and blasted the rock faces until the debris filled the gap from bottom to rim. It took 2 days and 2 nights of continuous work, and when the dust settled there was a crossing where there had been a void. The division rolled forward and reached Davao Gulf by May 2nd, finding the Japanese already retreating into the impenetrable jungles of the interior. The Visayan landings revealed a different kind of danger. On March 26th, elements of the Americal Division came ashore just south of Cebu City, expecting light resistance after the pre-invasion bombardment. The beaches had been expertly camouflaged. Within minutes of the first vehicles crossing the sand, 8 were destroyed by mines buried so carefully that the aerial photographs had shown nothing but undisturbed ground. No heavy enemy fire followed, only scattered rifle shots, but the beaches were now jammed with men and equipment arriving in successive waves, and the path forward was blocked by a killing zone. The engineers of the 52nd and 57th Combat Battalions worked frantically to open lanes through the minefield, while the beachhead grew more congested with every landing wave. The situation at Cebu could have become a massacre if the Japanese had counterattacked while the beach was paralyzed. But the bombardment had driven the main enemy force into the hills behind the city, leaving only the mines and a few snipers to contest the landing. The engineers cleared the mines, removed anti-tank ditches and log walls on the road to Cebu City, and got the column moving again before the defenders could organize a response. The city itself was deserted, and within days the engineers were rehabilitating the shattered airfield and constructing bridges across the shallow streams that threaded the coastal plain. The lesson was stark. A beach assault could be stopped dead, not by gunfire, but by the patient, silent placement of explosives, and only engineers could break that paralysis. In Manila, the General Engineer District was fighting a different kind of war against destruction. Colonel Robert C. Hunter had arrived in late March with his staff recruited from Engineer District offices across the United States, trained at Fort Belvoir, and flown to the Philippines. Their mission was to rebuild the capital using paid Filipino labor rather than combat troops, freeing the construction battalions for the advance north. Hunter's staff settled into the 3rd floor of Far Eastern University and found a city where every pre-war facility had been systematically destroyed during the Japanese retreat. The port was choked with 600 sunken vessels, the water system was severed, the power grid was wrecked, and the Pasig River bridges were blown. The engineers began clearing Manila's streets, stretching temporary Bailey spans across the river, and gradually restoring water pressure to the northern districts by connecting a 16-inch main across the Ayala Bridge. The scale of the Manila problem was staggering. 9 million square feet of covered storage, 34 million square feet of open storage, berths for Liberty ships, hospitals with thousands of beds, and power plants to run it all. Hunter's men started the harbour clearing immediately, pulling 200 sunken boats from the channels, while army dredgers excavated over 3 million cubic yards of silt and debris from North and South harbours. The first Liberty ship docked on March 17th, less than 3 weeks after the fighting for Manila ended. By the end of April, the General Engineer District had 30,000 engineer troops and over 20,000 Filipino civilians working simultaneously on the San Fernando staging areas, the Batangas depots, the Clark Field runways, and the ruined heart of the city itself. The organizational machine that Leif J. Sverdrup had built, the Engineer Construction Command, was absorbing the lessons of the campaign in real time. In mid-April, Philippine Base Section had transferred the Leyte Engineer District into the General Engineer District, consolidating more construction control under the Engineer Command. Sverdrup was also preparing to activate the Construction Corps of the Philippines, a new organization under Colonel Samuel N. Carrick that would organize Filipino laborers into formal labor battalions with American and Filipino officers. Each battalion at full strength would field over 1,000 civilians, paid wages, fed at cost, and permitted to buy scarce goods in the army post exchanges. Recruitment was slow at first, only 1 battalion by June, but the concept promised to relieve the chronic shortage of construction troops that had plagued every Pacific campaign. The construction tide was rising even as the combat engineers were still bleeding on the mountain trails. The airfield program alone was enormous. 20 runways on Luzon were being repaired or newly constructed in the first 6 months of 1945. At Clark Field, the engineers put 2 existing strips into temporary condition and then pushed 2 new 7,000-foot runways for heavy bombers through the same volcanic soil that would later torment the builders on another island. At Mariveles on Bataan, massive 40,000-barrel welded steel tanks were rising, the largest storage vessels ever erected in the Southwest Pacific, feeding a 6-inch pipeline that stretched over 50 miles to Clark and the surrounding airfields. Aviation gasoline was flowing at 412 barrels an hour by August, but even in May the system was already pumping fuel toward the bomber bases that would eventually support the invasion of Japan. Back in the mountains of northern Luzon, the stalemate at the passes was finally cracking. The 25th Division had captured Balete Pass on May 13th, and by May 25th it had reached Santa Fe and turned west onto the Villa Verde Trail to squeeze the defenders of Salaksak Pass from both sides. The 32nd Division, which had been fighting on that trail for 3 months, broke through the enemy strongpoints on May 29th and met the 25th Division coming east. The Villa Verde Trail was secured, but the engineers had already halted all new construction on it 3 days earlier. The road they had carved at such cost was now purely a maintenance operation, supplying the final drive down the Cagayan Valley. The 37th Division passed through the exhausted 25th on May 31st and began the dash north toward Apari. The 117th Engineer Combat Battalion moved forward with them, leapfrogging every 2 or 3 days to keep pace with the infantry. Highway 5 was in fair condition, but nearly every bridge was destroyed. The forward companies operated treadway ferries until permanent crossings could be thrown up, while the rear companies widened bypasses and repaired decks. At Bagabag, they threw a floating bridge across the Magat River and built airstrips by scraping gravel off the roadway and leveling existing grass strips with native labor. The flat, open valley gave the engineers speed they had not known since the Central Plains, and by late June the advance elements reached Alacan, 25 miles south of Apari, meeting patrols from the Connolly Task Force that had raced up the western coast. The destruction of Japanese organized resistance in the Philippines was nearly complete by the end of June. 8th Army had relieved 6th Army to handle the remaining mop-up operations, but the mop-up was no formality. 65,000 Japanese soldiers were still scattered through the mountains of northern Luzon, unorganized but dangerous. The engineers were already pivoting from combat support to base preparation, and the pace of construction was accelerating towards something far larger than the Philippine campaign. The planners at GHQ were now deep into the estimates for Operation Olympic, the invasion of Kyushu scheduled for that autumn, and every airfield and fuel tank and pier that the engineers built in the Philippines was being sized for the bomber streams and supply ships that would converge on Japan. At AFW ISPAC, the successor to USASOS, the engineer staff was now a vast organization of over 600 officers and enlisted men, controlling more than 200 engineer units numbering 65,000 men, fully a quarter of all troops under the command. The General Engineer District was handling rehabilitation of Manila at an unprecedented scale. Prefabricated steel hospital units assembled on assembly lines, quartermaster depots covering over an acre per building, 17,000 workers clearing and repairing 90 miles of streets. The theatre had learned from the chaos of the early campaigns in Australia and New Guinea, where engineer construction had been fragmented among base commanders who did not understand the work. Now every project flowed through Sverdrup's district offices, and the results were measurable in tons landed, barrels pumped, and beds ready for the casualties that were expected to come. But there was a friction that no organization could eliminate: the sheer shortage of well-trained men. The officer candidate schools in Australia and the specialist training courses at Base B could turn out mechanics and equipment operators, but they could not manufacture the years of construction experience that the senior sergeants and warrant officers had brought with them from civilian life. The heavy equipment was worked past any reasonable service interval, and the spare parts pipeline, though improved, still left dozers and cranes deadlined for weeks while cannibalized parts moved from one scrap machine to another. The floating depot concept, Liberty ships, stocked with spare parts and operated as mobile warehouses, had been tested at Leyte and was now being used to supply 8th Army units in the southern islands. But the system was still improvised, still fragile, still dependent on the same overworked shipping that was carrying everything else forward. On the Zamboanga Peninsula, the last months of the campaign were a grinding reduction of fortified positions that had never been designed to hold against a modern army, but which held anyway because the terrain was so brutal. The 116th Engineer Combat Battalion destroyed 50 caves and pillboxes, removed nearly 2,000 mines, and built 50 miles of roads and 16 bridges, each capable of carrying 35 tons. On Basilan and Jolo, the engineers repeated the pattern: clear the beaches, build the roads, restore the airfields, move on. The Sulu archipelago was the final stepping stone toward Borneo, and by mid-year the Australian landings at Brunei Bay and Balikpapan were closing the loop on the East Indies. The engineers of the 3rd Special Brigade supported the Australian beach assaults, and Royal Australian Engineers took over the inland work, widening narrow tracks and reinforcing swampy ground to handle the supply convoys. The Japanese oil supplies were severed, and the southern resource area was no longer feeding the Empire's war machine. The airfield program was the capstone of the entire engineer effort in the Philippines. 45 runways were rehabilitated or newly constructed during the first 6 months of the year, from the bomber strips at Clark and Porac to the fighter fields on Mindoro and the Visayas. The storage tanks at Mariveles and the pipeline network spreading across Luzon were building toward a capacity that could fuel the entire Far East Air Forces for the assault on Japan. The mapmakers were already at work in the Aguinaldo building in downtown Manila, the 648th Topographic Battalion producing the terrain models and airfield charts that would guide the invasion forces onto the beaches of Kyushu. The war was shifting from the islands of the Pacific to the home islands of the enemy, and every engineer structure in the Philippines was a link in that chain. The battered dozer blade on the Villa Verde Trail, holed by 18 Japanese shells, was a smaller artifact than the fuel tanks at Mariveles or the runways at Clark, but it told the essential story of the engineer war in the Philippines. The same men who built those bridges under fire and blew that gorge into a crossing and cleared that minefield on Cebu Beach had spent the previous year learning their trade on the jungle trails of New Guinea and the coral atolls of the Central Pacific. They had learned to improvise because improvisation was the only tool that always worked. They had learned to fight because the enemy always contested the ground they needed to build on. And they had learned to organize because the scale of what was coming, the invasion of Japan itself, would require not just courage and skill, but a supply chain and a command structure that could deliver the tools of construction to the edge of the battlefield before the first landing craft touched the shore. The island was a furnace that had risen from the sea. 5 miles long and 2.5 wide, Iwo Jima was nothing but volcanic ash in various stages of consolidation, from loose grit to soft sandstone. Mount Suribachi, an extinct volcano, formed the southern tip. The northern half was a flattened dome of heat, where steam vents hissed constantly, and the ground a few feet down was hot enough to blister a man's hand. The Marines hit the beach on February 19th, and 3 weeks of the most bitter fighting of the Pacific War followed before the island was secured on March 16th. The engineers who came after them faced a different kind of battle: how to build runways on terrain that actively resisted being paved. The strategic purpose was clear. Iwo Jima sat 800 miles south of Tokyo, perfectly placed as a staging base for B-29 heavy bombers and an emergency landing field for crippled planes returning from missions over Japan. 3 airfields were planned, a large one with 2 runways for the B-29s in the center of the island and 2 fighter fields to the north and south. Most of the construction was assigned to Navy Seabee units, but one Army engineer unit, the 811th Aviation Battalion, was scheduled to arrive as well. The problem announced itself almost immediately when the first asphalt mix was laid. The volcanic ash refused to bond, standard hot asphalt simply would not adhere to the loose ash. The surface crumbled under the weight of construction equipment. The engineers stopped paving and began experimenting. What they developed was a deliberate 2-layer bonding procedure. First, they spread a layer of crushed stone 2 inches thick across the ash and rolled it in with heavy compactors. When rain fell and the ash settled, the stones remained slightly exposed, creating a rough, interlocking surface. Onto this prepared base, they poured a 2-inch layer of hot asphalt mix. The stone and ash gripped each other, and the asphalt gripped the stone. The bond held. With the bonding problem solved, the runways began taking shape. The crushed stone method was applied to roads as well, and the island's transportation network grew. But a second, more bizarre obstacle soon appeared. Under the asphalt of the B-29 field, and one of the fighter strips ran a strip of especially hot ground, about 400 feet wide. After the surfacing had been in place for several weeks, soft spots developed. The asphalt began to crack. Steam, trapped under the impermeable surface, was condensing into water and saturating the ash beneath. Then the ground itself began to bulge. After a prolonged rainy period, parts of the asphalt surface inflated like blisters. Steam puffed from the cracks. The engineers diagnosed the problem. Volcanic vents were pumping heat and moisture upward, and the sealed runway had no way to release the pressure. Their solution was remarkably direct. They dug trenches from the sides of the runway to the steam vents and laid pipes in them to carry off the vapor. Where the surface was already bulging, they drove perforated 1-inch pipes through the asphalt, leaving the ends flush with the surface. The steam hissed out the edges of the runway instead of rupturing the pavement. It was a makeshift fix, but it worked. By late April, the 811th Aviation Battalion became the first Army engineer unit to arrive on the island. The battalion took over construction of North Field from the Seabees on the 27th. The runway was already operational, but there was still an enormous amount of work to do. Taxiways needed to be built and surfaced. Parking areas had to be laid out on the unstable ash. Warehouses, fuel storage, and access roads all had to be pushed to completion while the volcanic ground continued to shift and steam beneath the men's feet. The engineers were now maintaining a runway that was also a geothermal battlefield. The steam vent problem did not go away. In some areas, the asphalt continued to disintegrate under sustained heat, crumbling to powder. The engineers developed a countermeasure. They laid down another 1-inch layer of hot mix asphalt over the damaged sections, then drove additional vent pipes through the fresh surface. The pattern repeated: heat, saturation, bulging, splitting, repaving, venting. It was a cycle of repair that had no precedent in any field manual. The men learned to read the ground by the sound of the steam and the feel of the pavement under their boots. There was a deeper problem beneath the runways that no vent pipe could solve. The aviation gasoline storage and distribution system had to be buried underground to keep the pipes clear of the runways and taxiways. But the underground volcanic ash was hot. Miles of pipeline carrying fuel from tankers offshore to the airfields ran through ground that could heat gasoline to 170 degrees Fahrenheit. At that temperature, fuel could not be pumped directly into the bombers. It would vaporize in the lines or boil in the wing tanks. The engineers needed to cool the fuel before it reached the aircraft. The cooling solution was simple in concept, but demanding in execution. Spare storage tanks were erected near the airfields, tanks that were not connected to the buried pipeline system. About an hour before a mission was scheduled to take off, the hot gasoline was pumped from the underground mains into these surface tanks, where it could radiate its heat into the open air and drop to a safe temperature. Only then was it transferred into the waiting bombers. The procedure added a full hour to every refueling operation. It was a bottleneck, but it was the only way to keep the B-29s flying. The results vindicated the engineers' work. Colonel D.A. Morris, the garrison force engineer on Iwo Jima, later described the sight of hundreds of these mighty bombers coming into land, or 2-mile-long lines of them queued for refueling. The volcanic island, which had killed thousands of Marines in February and March, had become a functioning airbase. The B-29s that limped home from Japan with shattered engines and wounded crews could now set down on asphalt that had been literally cooled and vented into submission. The engineers had conquered the island's heat as thoroughly as the infantry had conquered its defenders. Far to the southwest, another island campaign was reaching its final phase. Borneo was the target, not for airfields, but for oil. The Japanese had drawn vital petroleum supplies from the great refineries at Balikpapan and Tarakan since seizing the island in early 1942. Allied planners wanted those supplies cut, and they wanted bases from which to sever enemy communications with the Netherlands East Indies. The first assault had gone in at Tarakan on April 30th, when Australian troops and a company of the Royal Netherlands Indies Army landed on Sandow Island after a withering naval and aerial bombardment. The second assault was scheduled for June 10th at Brunei Bay. The Brunei Bay operation went ashore without a fight. On that June morning, the 9th Australian Division landed on the beaches after a crushing naval bombardment. Enemy resistance was almost non-existent. The Japanese had pulled back into the interior, leaving only a few harassing air raids to contest the landing. The real opposition was the ground itself. The roads near the beaches on Labuan Island were narrow, unpaved tracks never designed for military traffic. The low-lying sections were swampy, churned into soft mire by the passage of heavy vehicles and the tropical rains that fell without warning. The amphibian engineers of the 3rd Special Brigade found themselves struggling not with enemy fire but with mud. The narrow roads near the beachhead funneled the unloading traffic into a bottleneck. Swampy sections collapsed under the weight of loaded trucks, and the engineers had to widen the roadbeds and lay down corduroy surfaces of logs and crushed stone to reinforce the soft ground. Every load of ammunition, fuel and rations for the push toward Balikpapan had to move over these hastily reinforced thoroughfares. Royal Australian Engineers took over the inland construction, pushing roads and bridges deeper into the island, while the Americans secured the beachhead logistics. The Balikpapan assault went in as scheduled on the 1st of July. The naval bombardment was among the heaviest of the campaign, and the Australian troops moved ashore against light resistance. The Japanese had fortified the high ground inland with the usual system of caves, pillboxes, and interlocking fields of fire, but the pre-invasion shelling had shattered much of their prepared defense. Engineers moved forward with the infantry, reducing the surviving fortifications with satchel charges and bulldozers. The great oil refineries that had fed the Japanese war machine for 3 years were now in Allied hands. The Borneo campaign severed the last of Japan's southern resource arteries. The oil that had flowed from Tarakan and Balikpapan through the Empire's tankers and refineries was now cut off permanently. The southern resource area that imperial planners had gambled on capturing was no longer feeding the war machine. Meanwhile, on Iwo Jima, the B-29 runways were handling hundreds of emergency landings that saved thousands of airmen's lives. The engineers who had fought the volcanic ash and the steam vents had built more than concrete and asphalt. They had built a gateway back from the skies over Japan, a gateway that the bombers passed through on their way home, brought down safely onto ground that had been tamed by crushed stone, vent pipes, and the relentless ingenuity of men who refused to concede defeat to an island's geology. The invasion fleet darkened the horizon off western Okinawa before first light. The landing beaches near Hagushi stretched for 6 miles, but between the transports and the shore lay a coral reef that ran the entire length of the assault area. The heavier landing craft could not cross it. Men and cargo had to transfer to tracked amphibious vehicles, and even the Duke trucks struggled to grind over the jagged coral barrier. The sound was a grinding mechanical roar, steel treads clawing at limestone, engines straining at full throttle. The 1st Engineer Special Brigade had the job of managing this chaos. The brigade was an organizational orphan, converted from a North African-era headquarters unit while still in England, stripped down to just its headquarters company with attached battalions. Its commander, Colonel Benjamin B. Talley, had inherited a shore party structure that had never trained together as a single team, and he had arrived from Alaska construction duty to take charge. The shortage of DUKW trucks and tracked landing vehicles was immediately obvious. Supplies began stacking up on the narrow beaches. Confusion spread as successive waves came in. Craft that missed their assigned landing points jammed into adjacent sectors. The reef prevented heavier vessels from pulling close, so every crate, drum, and pallet had to be double-handled across the obstacle. The beaches themselves were hemmed by bluffs and seawalls, vehicles bogged down in soft sand. The coordination between Navy beachmasters and Army shore parties had been planned in too little time. The result was a logistical bottleneck on a beachhead that had not yet faced serious enemy fire. Engineer teams moved into the reef itself with explosives and bulldozers. They blew passageways through the coral, carving channels where landing craft could nudge closer to shore. The work was wet and dangerous. Coral fragments flew with each detonation. Bulldozer operators worked in salt water up to their engine compartments, pushing shattered limestone into improvised ramps. By midday, the beachhead had absorbed over 50,000 men. The unloading chaos never became a disaster because the Japanese had abandoned their beach positions, retreating inland after the naval bombardment. The two airfields behind the beaches were seized within hours. Yontan and Kadena fell to the advancing infantry, while the sound of sporadic mortar fire still echoed across the rice paddies. Engineers moved onto the runways before the infantry had finished clearing the perimeter. The strips were damaged but not destroyed, cratered by American bombs rather than demolished by the defenders. Aviation engineer battalions began filling holes and scraping debris while rifle companies pushed through the surrounding cane fields. Kadena was operational for fighters within 4 days. Opposition remained strangely light as the troops pushed inland. By the second day, the 7th Division had reached the eastern coast, cutting the island in two. The 3rd Amphibious Corps turned north. The 24th Corps turned south. The engineers' main problem became the roads. The island's interior highways were narrow, single-lane, and only partly paved. They crumbled under the weight of trucks, tanks, and artillery, moving in continuous columns. Division and Corps engineer battalions began spreading coral and rubble from demolished villages to widen the crumbling surfaces. By the middle of May, the rains came with tropical violence. The skies opened and did not close for weeks. Southern Okinawa's roads dissolved into a slurry of coral grit and volcanic clay. Heavy trucks churned the surface into liquid muck. The engineers lost control of the road network. Supply convoys ground to a halt. The infantry on the front lines, locked in bitter fighting against a deeply entrenched enemy, began running short of ammunition, rations, and medical supplies. In the 24th Corps sector, the situation collapsed to a single artery. Only one main supply route remained passable, and even that required continuous emergency maintenance. Bulldozers and graders worked in shifts through the downpour, scraping new coral from nearby quarries and spreading it over the liquefied roadway. Traffic moved at walking speed. Trucks sank to their axles. Engineers stood in the rain with shovels, hand-clearing drainage ditches that filled faster than they could dig. The work never stopped. As soon as one section was stabilized, another half-mile ahead collapsed. The decision was made to feed the entire Corps logistics effort through that one surviving road. Corps engineers took over the northern half. Divisional engineers held the southern sections closer to the front. The men worked in knee-deep mud, laying coral aggregate brought forward by dump trucks that themselves frequently bogged down. Japanese kamikaze aircraft dove on the supply columns, but the engineers stayed on the road. The alternative was the collapse of the entire offensive. The infantry on the Shuri line could not advance without shells, fuel, and plasma. The bridges were failing too. Okinawa's pre-war concrete spans had been built for farm carts and light vehicles. Under tanks and heavy trucks, the reinforced structures cracked and sagged. Japanese artillery scored direct hits on several key crossings. Bailey Bridge sections came forward on long flatbed trucks, the green steel components swinging through the rain. Engineers assembled the spans under intermittent shell fire, bolting together panels while water rose in the streambeds below. The one-lane Baileys proved their worth. A bridge could go from wrecked to passable in hours. The rains did more than destroy roads. They revealed a fundamental organizational weakness. Corps and divisional engineer battalions, designed for combat support and light construction, were now performing heavy road maintenance with improvised materials. The specialized construction groups that should have handled this work were still unloading at the beaches or diverted to airfield projects. The line between combat engineers and construction engineers blurred. Every available dozer, grader, and dump truck was pressed into road service regardless of its unit assignment. The single supply route held. Through the worst of the May rains, the ammunition and rations kept moving. The slow, grinding offensive against the Japanese defenses south of the Shuri line continued. The price was paid in engine overhauls, broken axles, and exhausted men. Equipment maintenance became impossible. Bulldozers ran until their tracks seized. Trucks operated with broken springs and leaking radiators. The engineers kept the road open, not through careful planning, but through sheer relentless physical labor. The enemy's defensive system on southern Okinawa was the most elaborate cave network American forces had ever faced. The Japanese had transformed the rocky terrain into a honeycomb of interlocking positions. Caves were cut into cliff sides, sometimes 2 or 3 stories high, with openings so small they were almost invisible. Machine guns and mortars covered the approaches. Each cave mouth was mutually supporting, the entrance of one protected by fire from others to the front and flanks. The Japanese had learned from every previous island battle and designed a defense with no blind spots. Engineer demolition teams became the primary tool for destroying these positions. The standard squad was small, 6 to 12 men attached to an infantry battalion. They waited near the command post while the rifle companies probed forward, prepared satchel charges, and listened to the radio reports of positions that could not be taken by direct assault. When a cave resisted tank fire, artillery, and aerial bombardment, the call went to the engineers. The squad moved up through terrain already swept by machine gun fire, carrying canvas packs of TNT and white phosphorus grenades. The technique was brutal and effective. The lead man advanced on the cave mouth with a satchel charge and phosphorus grenades. 1 or 2 others followed with spare charges. The rest of the squad covered from whatever cover existed. At the cave entrance, the lead man threw phosphorus grenades to blind the occupants. Then the satchel charge went in, fused for 10 to 15 seconds, hurled as far toward the rear of the cave as possible. Multiple fuses, some of them dummies, made it nearly impossible for the defenders to deactivate the charge before detonation. The engineers ran. The blast sealed the cave and collapsed its firing ports. The human cost was severe. During one 3-week period, a single engineer combat battalion suffered 20% casualties among its demolition teams. The Japanese defenders brought intense small arms and mortar fire down on any engineer squad spotted near a cave mouth. Grenade duels erupted at close range. Hand-to-hand fighting broke out when defenders rushed out to prevent the satchel charges from being placed. On Aishima, the small island off Okinawa's northwest coast, the 302nd Engineer Combat Battalion destroyed over 560 fortified positions in fighting described as the bloodiest of the Pacific War. 11 men killed, 49 wounded. The island was strewn with every kind of mine the Japanese could improvise. The cave mouths were concealed with exceptional skill. The Japanese cut firing ports so narrow they appeared as shadows or rock crevices. The defenders held their fire until engineers were within 20 feet. Then the machine gun would open from a position that had been invisible seconds before. The engineers learned to approach from oblique angles, using smoke and covering fire. They learned that the first satchel charge had to be thrown immediately upon reaching the cave mouth. Any pause invited a grenade from inside. The work was a test of speed above all else, speed and the nerve to advance directly into the kill zone. The reduction of the cave defenses became an integrated system. Infantry tank teams worked the outer positions with direct fire and flamethrowers. 8-inch howitzers from the artillery fired point-blank into hillside openings. Aircraft dropped bombs within meters of friendly lines. Then the engineers moved in for the final sealing. The satchel charges were thrown and the caves collapsed. The Japanese had built the most advanced cave defense of the war, but they could not escape the simple physics of a 24-pound explosive charge detonated inside a confined space. The overpressure killed everything within. Through all the rain and combat, the airfield construction program had continued. By the end of June, 5 operational airfields existed on Okinawa and Aishima, Kadena and Yontan, captured on the first day, had been transformed from cratered strips into fully equipped bases. The medium bomber runway at Yontan stretched 7,000 feet of compacted coral and asphalt. On Aishima, the airfield complex had expanded until it occupied nearly the entire island. The civilian population had been evacuated to make room for runways, taxiways, and hardstands. The island was becoming a stationary aircraft carrier. The original plan called for 6 B-29 runways on Okinawa, but the final program expanded to 22 runways on 13 airfields, spread across Okinawa and Aishima. The scope was staggering. Army facilities had to support 450,000 men. Storage tanks for nearly 2 million barrels of aviation gasoline had to be erected. Pipelines laid from tanker berths to the flight lines, pumping stations installed to push fuel across miles of coral terrain. The construction force grew to include naval Seabees and Army engineer battalions working side by side under the island command. 6 additional airfields remained under construction as the fighting continued. At Bolo Airfield on the western shore, a new B-29 runway was taking shape through the coral rock. At Futema, another heavy bomber strip was being developed. The work was hampered by the same rains that had destroyed the roads. Bulldozers and scrapers bogged down in the excavation areas. Drainage ditches overflowed. The heavy equipment, already exhausted from weeks of continuous operation, broke down faster than repair crews could fix it. But the program kept moving forward, driven by the knowledge that these fields would launch the first waves of the invasion of Japan. The B-29 runways on Okinawa were built differently from those on Iwo Jima. There was no volcanic ash to contend with, no steam vents hissing through the pavement. Instead, the engineers dealt with coral and limestone. The coral was crushed, graded, compacted, and capped with asphalt. The resulting surface was hard and durable, capable of taking the impact of a fully loaded superfortress landing at over 100 miles per hour. The excavation was the hardest part. The limestone bedrock resisted bulldozers and required blasting. The sound of drilling and dynamite became as constant as artillery on the front lines. The operational impact was immediate. Tactical aircraft flying from Kadena and Yontan provided close air support to the infantry grinding southward. The response time shrank from hours to minutes. When Japanese positions held up an advance, fighter bombers could be overhead almost before the infantry had finished calling for support. The airfields directly enabled the final reduction of the Shuri line and the pursuit of the defenders into the southern tip of the island. Ground and air forces were now linked in a continuous tactical loop that the Japanese could not disrupt. The campaign was declared officially over on the 2nd of July. 340 miles of road were under maintenance. Temporary ponton piers lined Buckner Bay, where Liberty ships unloaded supplies for the growing garrison. The engineers had built supply roads down both coasts and across the center of the island. Gasoline was flowing through pipelines to the major airfields. The island that had been a rural prefecture of 65,000 people had been transformed into the largest forward operating base in the Pacific. It was now ready for the mission that had justified its capture, the final assault on the Japanese home islands. The war's final act was not written in blood, but in the ledgers of engineers. By early June, the staff sections across the Southwest Pacific had turned to a single overwhelming task, estimating the tonnage of victory. In offices from Manila to Hawaii, officers with slide rules and cargo manifests calculated what it would take to put an army on the Japanese homeland and keep it fighting for months to come. The chief engineer of the Southwest Pacific area, Hugh J. Casey, sat at the center of this storm of arithmetic, receiving daily estimates from his subordinates that each day grew larger and more complex. The invasion plan had a name now: Olympic for Kyushu, Coronet for Honshu. Behind those code words lay a construction program that dwarfed everything that had come before. The numbers were staggering even to men who had built airfields on coral atolls and floating docks in jungle harbors. The engineer of 6th Army, Samuel D. Sturgis Jr., received the preliminary troop lists and checked them against his own experience from Luzon. The Olympic assault alone would require over 117,000 engineer troops out of a total force of more than 500,000 men. Combat engineers would make up 20% of the assault echelon. Service and aviation engineers would account for nearly 23% of the logistical tail. Every division needed its battalion. Every corps demanded its construction group. Every airfield required its aviation regiment. The base at Kushikino, on Kyushu's western coast, had to support 400,000 men alone. Planners specified berths for 10 Liberty ships because ammunition and rations could not wait offshore while lighterage crawled back and forth. 2 all-weather runways had to be operational within weeks, carved out of terraced Japanese farmland. Storage for 205,000 barrels of aviation gasoline had to rise from nothing, with the pipeline laid before the first tanker docked. 220 miles of road had to be surveyed, cut, and surfaced. 3 hospitals with over 13,000 beds had to be assembled. The smaller bases at Shibushi and Miyazaki added their own demands. On paper, the theater needed 144 prefabricated steel warehouses at Kushikino alone, each covering an acre of ground. The commanding general of the Engineer Construction Command, Leif J. Sverdrup, looked at the troop allocations and saw a familiar problem. There were not enough construction battalions. His organization, AINCOM, had centralized construction control across the communications zone, but centralization could not manufacture units. Some of his heavy shop companies were already cannibalizing worn-out dozers to keep half the fleet running. When the War Department authorized 4 additional construction brigades, Casey pressed for them to be shipped immediately. The loading plans called for construction materials to be phased ashore in precise sequences, every beam and barrel arriving exactly when needed, because there would be no local procurement on a hostile shore. Simultaneously, the coronet estimates for Honshu were taking shape in another floor of the same Manila office building. This was the strike at the industrial heart of Japan, the assault on the Tokyo-Yokohama plain, and its engineer requirements eclipsed even Olympic. The preliminary annex called for 11 all-weather runways completed in 3 months, 171 lighter berths, 7 floating Liberty ship berths, and nearly 8 million square feet of covered storage. Garrison camps for 500,000 men, hospital beds for over 42,000 casualties, camps for replacements, prisoners, and civilian internees. The total construction supply requirement reached a staggering 1,016,591 deadweight tons. On June 7, the first gasoline reached Kunming through the final segment of what was now the largest military pipeline system in history. The 4-inch line from Assam stretched 928 miles across the Patkai Mountains, down the Lido Road corridor and into the tank farms at Kunming. It joined the 6-inch line from Tinsukia, the spur lines from Calcutta, and the networks feeding airfields across Yunnan province. In total, the engineers had laid over 3,300 miles of pipe and built 148 pumping stations across 3 nations. The pipeline was a monument to brutal improvisation. When the 6-inch H20 bridges for the Ledo Road had been delayed, the engineers fabricated steel parts from scrap metal in advanced section depots. When Bailey Bridge components proved scarce, they learned to erect them faster and with fewer men. When the Irrawaddy rose 40 feet during monsoon floods, they designed hinged floating spans that rode the river's surface while maintaining a continuous 2-lane capacity for 35-ton trucks. The entire system, from the Brahmaputra barge terminals to the last pumping station in China, had delivered over 462,000 barrels of fuel to points that 3 years earlier had been accessible only by footpath and pack animal. The fuel sustained the 14th Air Force's aircraft that were now operating over Japanese-held cities in southern China. Fighter sweeps from Luqiao escorted bombers that struck supply columns and rail yards. The airlift over the hump, once the sole artery into China, now hauled over 70,000 tons in July alone, because the bases in Assam were fully developed and the pipeline had freed transport aircraft from hauling their own gasoline. Yet the pipeline's completion was also a valedictory. The combined chiefs had already decided that the decisive blow would come from the Pacific Islands, not from the Asian mainland. The engineers who had built the Lido Road and strung pipe through the Hukang Valley were now maintaining what they had built, preparing to hand it over, and waiting for reassignment. The mapping of Japan consumed the topographic battalions in Manila and Hawaii. The 648th Topographic Battalion had moved from Melbourne to the Aguinaldo building in downtown Manila, taking over a former department store and converting display floors into map compilation rooms. Their presses ran 24 hours a day, producing terrain models of Kyushu's beaches, overlays of road networks around Kagoshima, and stereographic charts of the hills behind Ariake Bay. The photographic coverage was arriving from multiple sources: Far East Air Forces squadrons out of the Philippines, marine photographic units from Okinawa, and Navy flyers returning from strike missions. The conference in Hawaii in late spring had finally sorted out the overlapping responsibilities, giving MacArthur primary control of mapping operations and ensuring that every unit received the same base data. But the photographs themselves revealed an unsettling fact. Pre-war Japanese maps, long the standard reference, were dangerously outdated. Entire industrial zones had been concealed. Roads had been rerouted. Coastal fortifications appeared where charts showed empty beaches. The geological teams that had studied Iwo Jima's volcanic ash moved on to the next target. The Engineering and Terrain Intelligence Team in Honolulu, a small group of civilian scientists from the United States Geological Survey pressed into uniform, had prepared dozens of studies for Okinawa. Now they turned to southern Kyushu, analyzing aerial photographs to determine beach gradients, soil load-bearing capacity, and the likelihood of encountering the same volcanic ash that had nearly defeated runway construction on Iwo Jima. Their reports went directly to Sturgis and his counterparts, feeding into the landing site selection process. The terrain intelligence teams had become an indispensable part of the engineer planning cycle, replacing guesswork with data. Their counterpart in the Southwest Pacific, working out of Casey's office, concentrated on Honshu, producing similar studies of the Sagami Bay beaches and the Kanto Plain west of Tokyo. On the 14th of June, the Joint Chiefs of Staff approved a directive that had been in discussion since the spring. A plan for the peaceful occupation of Japan, code-named Blacklist. The directive was brief, and its implications were enormous. Instead of fighting ashore and building bases under fire, the engineers would now plan for rehabilitation, for the use of existing Japanese facilities, and for the maximum employment of local labor and resources. MacArthur issued his basic outline on the 25th of the month. 6th Army would occupy the western half of the home islands, 8th Army the eastern half, and 10th Army would take Korea. The construction requirements that had consumed thousands of staff hours suddenly contracted. There would be no Kushikino base, no prefabricated warehouses on Ariake Bay, no clearing of fields of fire on Miyazaki Beach. For the engineer staffs, the transition was vertiginous. Casey ordered that all Olympic planning continue at full speed, because the directive specified that Blacklist would take effect only after surrender or collapse. The invasion was still scheduled for the 1st of November, and the engineers could not afford to be a day behind. Yet the coronet estimates still in draft took on a ghostly quality. The 1,016,000 tons of construction supplies that had been calculated for Honshu represented an investment in shipping and production that was already being questioned. Every Liberty ship loaded with prefabricated steel for a hospital that might never be built was a ship that could not carry ammunition or rations. Sverdrup, from his desk at ENCOM, watched the cargo manifests being revised and revised again, the weights shifting from heavy construction materials to the lighter requirements of occupation, water purification units, portable generators, bridge repair components. The construction corps of the Philippines, which Sverdrup had activated with such difficulty, now became a model rather than an experiment. Colonel Carrick's battalions, each with over 1,000 Filipino civilian laborers under American and Philippine scout officers, had proven that organized local labor could handle large-scale construction. The turnover that plagued the early months had stabilized as workers recognized the value of steady wages and access to Army post-exchange goods. In June and July, 4 additional battalions were activated, and the Corps took over an increasing share of road maintenance and warehouse construction in the Manila area, freeing combat engineers for the tasks that only they could perform. The Blacklist planners studied this model closely. The occupation of Japan would require exactly this kind of organization: American supervision, local execution, and a rapid transition from military to civilian standards. The global supply pipeline, the massive logistical system that had been built from the factory floors of Detroit to the floating depots of Leyte, faced its final realignment. The War Department had authorized the shipment of depot groups to supervise the enormous forward stockpiles that Olympic required. But depot groups had never been popular with engineer commanders. The chief engineer of what was now Army Forces Western Pacific wrote a blunt assessment. The Corps of Engineers was simply not sufficiently supply-minded. It understood construction brigades. It understood combat groups. It did not understand the intricate machinery of stock control, the endless catalogues of spare parts, and the necessity of keeping depot personnel trained and in place. The floating depot concept, tested at Leyte with Liberty ships converted to floating warehouses, had worked well enough for a campaign of weeks. For a campaign of months on Japanese soil, something far more robust was required. The contradiction at the heart of the engineer effort in the late summer was this: they were building for a war that everyone hoped would not be fought. The lines of pipe from Assam to Kunming were pumping fuel that might soon have no strategic purpose. The airfields on Okinawa, still under construction in the monsoon mud, were designed for bombers that might never take off. The maps of Honshu beaches, stacked in the Aguinaldo building, might become historical curiosities. Yet the engineers kept building, kept planning, kept estimating, because the alternative was to assume a peace that had not been offered and could not be trusted. When the atomic bomb fell on Hiroshima in the first week of August, the engineering corps was deep in the final stages of invasion preparation. Within days, the war would end, and the entire colossal apparatus would pivot to the task of rebuilding what it had once been ordered to destroy. The atomic bombs fell, and the Japanese government fell silent. For 3 days after Nagasaki, the engineer staffs in Manila worked on 2 sets of plans simultaneously: the final loading manifests for Olympic and the occupation directives for Blacklist. Teletype machines clattered with revised shipping schedules. Prefabricated hospital units bound for Kushikino were relabeled for Yokohama. The invasion stockpiles that had consumed a year of planning became surplus in a single morning. Nobody celebrated yet. The machinery had been built for assault, and stopping it was almost as complex as starting it had been. On the 30th of August, the first American aircraft touched down at Atsugi Airfield west of Tokyo. Paratroopers of the 11th Airborne Division stepped onto the concrete, weapons ready, scanning the hangars and the silent anti-aircraft positions. Japanese officials stood waiting on the tarmac. Behind the airborne infantry came the advance elements of the engineer units that would transform Atsugi from a receiving point into a functioning base within hours. They carried portable generators, water purification tablets, and bridge inspection kits instead of satchel charges. The occupation had begun. 6th Army engineers entered the western half of Honshu. 8th Army units fanned out through the eastern prefectures. The 10th Army prepared for Korea. Everywhere they moved, they found the same scene: industrial cities hollowed by firebombing, ports choked with sunken vessels, railways severed at water crossings, and electrical grids reduced to tangled copper. The infrastructure that planners had expected to destroy was already destroyed, and the engineer mission inverted from demolition to restoration within 48 hours of the ceasefire. Harbour clearance became the first priority. The same army dredges that had excavated over 3 million cubic yards of silt from Manila Bay received immediate orders for Tokyo Bay and Yokohama. Floating cranes and salvage companies that had pulled 200 sunken boats from the Pasig River shifted their barges northward. The work was grim and silent. Sunken coasters, ferries, and naval auxiliaries lay on their sides in the shallow water, masts and funnels breaking the surface. The dredge crews worked around the clock, cutting channels wide enough for Liberty ships, bringing food and medical supplies. The construction corps of the Philippines became the administrative model for an entire occupation. Colonel Carrick's experiment with paid civilian labor battalions, slow to start and plagued by turnover in its first month, proved that local workmen under engineer supervision could rebuild faster than troops alone. Japanese laborers were hired under the same framework. Existing factories, power plants, and water systems were surveyed not for demolition charges, but for repair estimates. Prefabricated steel warehouses intended for Kyushu staging areas were redirected to shelter displaced civilians in the Tokyo plain. On the 2nd of September, the battleship Missouri rode at anchor in Tokyo Bay, grey and immense under a flat, overcast sky. The formal surrender ceremony lasted 23 minutes. General MacArthur signed first, then Admiral Nimitz, then the Allied representatives in succession. The Japanese delegation stood rigid in formal dress. When the last signature dried, the Second World War ended. The engineer officers watching from nearby vessels understood that their work had just shifted into an entirely new phase, one for which no operations instructions had been thoroughly rehearsed. The engineer effort can be measured in numbers that stagger even a professional. In the Pacific alone, 700 engineer units, totaling 235,000 men, had served in a theater army of nearly 1.5 million. They had built or rehabilitated thousands of airfields from Fiji to the Ryukyus. They had laid over 3,300 miles of military pipeline across India, Burma, and China, a system with 148 pumping stations that delivered nearly 500,000 barrels of fuel into Kunming. They had constructed floating piers, coral runways, steel bridges, and volcanic asphalt landing strips on islands that had never seen a wheeled vehicle before the war. The after-action reports that reached the chief engineer's office in the months after the surrender contained a recurring phrase: the terrain was more of an obstacle than the enemy. The Villa Verde Trail had cost more casualties to geography than to Japanese fire. The coral reef at Okinawa had nearly paralyzed the beachhead before a single defender opened fire. The volcanic ash of Iwo Jima refused to bond with standard asphalt and required an entirely new pavement technique under combat conditions. The war in the Pacific was as much a conquest of earth and coral and jungle clay as it was a conquest of an armed empire. The Bulldozer stood alongside the aircraft carrier and the long-range bomber as one of the three machines that made Japan's defeat inevitable. It carved roads out of mountain trails, buried enemy cave positions, cleared beach obstacles under direct fire, and pushed crushed coral into runway surfaces, while naval gunfire still arced overhead. No other army in the world had deployed heavy earth-moving equipment in direct combat support on this scale. The Japanese defensive doctrine, built on caves and reverse slope positions, collapsed not under firepower alone, but under the relentless physical reshaping of the battlefield by engineer machinery. The transition from combat engineering to reconstruction happened so rapidly that many units completed both missions with the same equipment. Dozers that had sealed cave mouths on Okinawa in June were grading roads for civilian truck traffic outside Nagoya in September. Floating ponton piers that had berthed Liberty ships under kamikaze attack in Buckner Bay were dismantled and re-erected as temporary wharves in Kobe. The same engineers who had learned to throw satchel charges into pillbox openings now trained Japanese work crews in concrete repair and water main installation. The institutional memory of this campaign shaped the core of engineers for the next half-century. The centralized command model that Sverdrup fought to establish became the standard for theater engineering organizations in Korea, Vietnam, and the Gulf. The floating depot concept, tested at Leyte and refined through the final campaigns, entered the logistics doctrine as the prepositioned ship. The construction corps experiment in the Philippines proved that civilian labor battalions could free combat engineers for tactical missions, a principle that guided reconstruction efforts in every subsequent conflict. The pipeline technology developed along the Lido Road informed the cross-country fuel systems of the Cold War. The story of these engineer units belongs to the men who served in them, and their families carry memories that no documentary can fully capture. If your father, grandfather, or relative served with an engineer aviation battalion, a combat battalion on the Villa Verde Trail, a special brigade on Okinawa, or a pipeline company along the Lido Road, please share their stories in the comments below. We read every one, and those personal recollections are the real historical record. Subscribe to the channel and like this video to support more documentaries on the engineering history of the Second World War. Thank you for listening.